Go.
Okay, so how many electrons you have put in here? So what you have done is you have taken the hydrogen's electron, you put it around the nitrogen. I don't think that's a good idea. Is that how all of you would do it?
No.
So you take away the hydrogen's electron, you put it here. The nitrogen's electron, you put it next to the hydrogen.
No, but there's nothing wrong with that.
No, there's
Nitrogen
nothing
is
wrong.
more electronegative. The electron will be closer to nitrogen.
No, there's nothing wrong with it. He's trying to make.
Okay.
He's trying to differentiate the electrons that come from.
Right, so now you have, nitrogen has its full octet and hydrogen has 2. So one of the things to know about the Lewis dot structure is, and students miss it. Who can tell me what it is that students miss a lot? The lone pairs.
Yeah.
All of the valence electrons have to be put in. And then when you see the IB mark scheme, and it shows that this is what you have to have, and the student doesn't have the lone pair,
You get 0.
and then you feel the teacher is being mean. I would love to give you some marks for it, but IB is not going to give it to you. So this is how you must do it. The idea, Kushal, of putting in the circle and all of those, that's not necessary. It's just going to complicate things. So draw all of these for us, and then we'll talk about the shapes. Right, so then we have boron trifluoride, BF3. What's special about BF3?
It has an incomplete.
Octet.
Right, it has an incomplete octet. What does that mean, Kushal? You don't know? Can someone help him to say it has an incomplete octet?
I mean, in the inner the borons, outer orbitals just have 4. I mean, 6 electrons.
6 electrons, right?
Rather
It
than
starts with 3 and it's only forming 3
Bonds.
single bonds. Okay, so this is going to lead us to a question for HL students after, but let's go on with the SL things, which is all of the shapes. Is that coming on the screen, Sid?
Make the next one below all of them. The one
Make
after.
the next one below.
But that's the last one.
Oh, that's the last one. Yeah.
Right. So now what you have done is the Lewis dot structures. Right? Again, you have included all the lone pairs. You can see, especially here. This is where I think a lot of times you see students neglect the lone pairs. 3 lone pairs here, and they don't include it. Here there's a problem here. Though. What's the problem there? You've put 2 electrons kind of like next to this, suggesting that it's,
That won't matter.
well, it wouldn't be technically it would
Just
matter.
put it down, yeah.
But you
But it's
should
better
take
to
this
put it
out.
down.
You see, it matters when you use this, when you apply this, which the purpose of it is to find out shapes. So by organizing it in the right way, it would help you to explain the shape. So put a
But
lot
when
there.
you give that like full marks, even if someone like did that.
So that's one lone pair. No, put 1 lone pair here. another electron there, and another pair over here. Right. Now, Kushal, tell me the shape in terms of electron domain geometry and molecular domain
That's the
geometry.
part I wasn't sure of.
This is the part you're not sure of.
Oh,
Okay. Well then, I want to call somebody else who is sure of it to explain. Who wants to come?
no, you can go. Huh?
Who wants to come? Come, sis.
So, okay. So,
Okay, Kushal. Good job.
So then through this we can look into electron domain geometry and molecular geometry, and the difference is very much defined within the name. As electron domain geometry looks at, it considers the electron domain, so it also considers the lone pair. And it also looks at how the lone pair would affect the other bonds that are taking place within the molecule. Whereas molecular geometry just looks at the atom as a whole, without considering the actual, it still considers the lone pair, but it doesn't consider the pushing or the repulsion between the lone pair, bond pair that takes place within a molecule. And another thing that is important to note is that what we see in a lot of these molecules is that lone pair repulsion is the greatest, then that is followed by lone pair, bond pair, and then it is followed by, or the least repulsion occurs between the bond pair and bond pair. And so for NH3, we see that there are 4 electron domains. And so according to its molecular geometry, without considering the actual pushing or pulling, this would be classified as a tetrahedral. But since it has a lone pair, because of the pushing that takes place between these bonds, the actual shape or the electron domain geometry of this would be trigonal pyramidal, I believe. And then BF.
All right, before you go on,
Yeah.
now we've brought out something that is an important point for us. The electron domain geometry is not trigonal pyramidal. Who can say what it is? It's tetrahedral.
Oh, did I do it?
Now that you've heard what it is,
Oh my god, okay. so
tell me what it is now.
Okay,
Tell me why it's tetrahedral.
that's because it's the electron domain geometry. So, oh, okay.
Which
Full
means-
electron domain.
See, that's why I was thinking in my head.
That's what you said. It means that this has to be considered a part of the whole thing.
Yeah.
It doesn't have anything there. It's just electrons, but it has to be considered a part, which then going to make it this.
Molecular geometry.
And then this is also commonly known as the shape
Yeah.
of the molecule.
Yep. Actually,
That would be trigonal.
this would be trigonal pyramid. Never mind. Correction. I'll start all over again from that.
Touche.
Okay.
Right.
So should I start again?
No, don't start again. So then you will do.
Yeah. BF3.
Don't do BF3. We'll leave BF3 for a while and we'll do call someone else. Let's ask you to do H2O.
Okay.
So get H2O right for us. Tell us what goes here.
Goes here. Oh, like ED.
What's its EDG?
EDG would be, again, it has, so what we see is that H2O has 2 lone pairs and 2 bonded pairs, and since that would come up to be 4 electron domains, the geometry of H2O would again be tetrahedral. But considering that for the molecular geometry of H2O, we see that there are 2 lone pairs that are present within the molecule, which would then make it a bent molecule, V-shaped kind of molecule where the angles would be around 120.
No, don't talk about the angles.
No.
Just fill this out for me, Sid.
104.
Let's fill that out for me. We'll
Okay.
talk about the angles in a minute.
Sir,
Yes.
Wait, it would,
should I ask a question?
Go ahead, ask.
Yeah, when you say H2 was like a bent shape, would it come under electron dot geometry or something else?
No. Okay, Sid. Now, when you say it's a bent shape, it's going to come under molecular geometry because there are 2 lone pairs that are going to be pushing. And now, what did you say earlier about lone pair, bond pair, repulsion?
So,
thing?
what takes place is that what we see is that lone pair repulsion is the greatest, followed by lone pair, bond pair, and the least repulsion that can take place within a molecule is between a bond pair and bond pair. So that is what really, this is why we see that it's more of a V bend shape since the 2 lone pairs are here, which would cause a greater repulsion downwards towards the bonds, and therefore it would consider to be more of a weak and
Okay, Sid. Now, why did I draw this here?
because well, this would be the angle if it was a pure if it was an ideal tetrahedral. As in a tetrahedral, the angle between the bonds is 109.5. Then if there's a lone pair in a tetrahedral electron domain geometry, the angle then decreases to about 107 degrees. And then for H2O, since it has two lone pairs, the repulsion is greater, and so the angle then decreases to about 104.5 degrees, which would be the case for H2O.
Okay, let's ask you a question about
Yes.
CH4 then, Sid.
Yes.
Why is it going to have the same answer for both of these?
This is because CH4 is considered to be an ideal tetrahedral, but since what we can see in both of these cases is that the only reason why the EDG and MG differ is due to the electron lone pair. But what we can see in CH4 is that there are no lone pairs. All the bonds are bonded pairs, which is why even when considering the molecular geometry, since there are no lone pairs, it would be still considered a tetrahedral, and the angle would be 109.5 in both cases.
Okay. Yes, thank you, Sid. Yes, Abhinav.
No, just adding to
Now-
the central thing.
Now, about BF3, it's special because you have just 6 electrons in the outer shell of boron, and this is what exists. But what happens, what type of bond do you call it, when one of the atoms in the covalent bond supplies both electrons? What do you call that?
Coordinate covalent bond.
Now, when you look at BF3, don't you see the possibility of one of these lone pairs forming a coordinate covalent bond and giving boron its octet? Isn't that like something that you might feel is logical? Why didn't that happen?
Because fluorine is very
Electronegative.
Well, yes, but it didn't happen, and that could be an explanation. But if this is given as one structure, here, and someone proposes this as a possible structure, if someone proposes this as a possible structure, not putting in the valence electrons here right now,
It's called
then how would you decide theoretically whether this is the favored structure or this is the favored structure? This is a question.
Formal charge.
Formal charge. So formal charge is, again, it's just a theoretical thing that's been developed in chemistry to decide which of two possible Lewis structures is favored. And then you plug in the formula for formal charge. Okay? And the people in the other class went over that last time, and there's a video with Chirag explaining all about that with us. So that will go up also to complement this. Yes, I think Kushal missed CO2, but we don't need it. We get the point of all of this. And one of the things that students of IB chemistry need to be aware of is from the 2016 exam and after that, the term shape is not used in exam questions, but it's molecular geometry. And when you do past papers and you see shape, sometimes I would give you an exam and you see shape, you're not sure if to do this or this. But in your exam, because you're following the new syllabus, not the old one, it would be clear whether you should have EDG or MG. Okay? So, you can stop it there for me, Sid.